Hello, welcome to CMU CS Academy CS Ed Week. Today we're going to be talking about 3D graphics, very simple 3D graphics, and how to implement them. So the main thing with 3D graphics is, of course, the three dimension, because the canvas only has two dimensions, X and Y. But real life, and 3D objects, they have a third dimension, which is usually called the Z axis. And so we're going to figure out, how we can take a 3D object. In this case, it'll be a cube, and we can draw it on our canvas and move around and look at it from different angles. So there's something to consider when you're drawing a cube. First of all, of course, it has 6 faces, but you might notice that you can only see up to 3 faces at a time. So that's something that we're gonna have to keep track of. Um, Also, in general, the corners of the cube, they're in one set of coordinates in 3D space. We're gonna have to convert that into 2D space. Although we're not actually going to do all the math for that, it involves a lot of linear algebra, and that's beyond the scope of this video. So we're just going to take it for granted that we have a function to convert 3D coordinates from 3D coordinates to 2D coordinates. But there's still some work to do, even if you have that functionality already. So just on a broad scale of what we're going to have in our code, we're going to figure out where the cube is, although it's not going to move in this example, where the camera is and where it's looking, and also which faces of the cube are visible. And again, the function to convert 3D coordinates into 2D coordinates will be helpful, and maybe some sub-functions to draw the planes of each, the faces of the cube, and to move the camera around, like if you move the mouse around. So I'll go into a little bit more detail about some of these functions. So draw block is going to see where the camera is and see where the cube is. And based on that, it's going to call draw plane. And draw plane is going to draw each of the 3 faces of the cube. And it's going to convert where the cube is in 3D space into 2D space. And then it'll end up drawing a polygon to represent what would be a square in 3D space. And finally, there's move view angle, which we won't get too much into how that works either, but basically it just moves the camera around the cube so that you can look at it from different angles when the mouse is moved. And with that, we will get into the actual coding. All right, so now we're looking at the code. I've set it up so that we can see the sample solution of what we're making. Now, it's not a cube. Each of the side lengths is different. So you can see it's 0.5 for the length, 1 for the width, and 1.5 for the height. And that's just so that we can tell them apart, and they're not all just 1. But of course, if you wanted to make a cube, you would simply just change all of these numbers to 1. Yeah, so as you can see, it just rotates around horizontally, nothing too fancy. I wanted to keep it simple, so that hopefully it's not too hard to understand how all of this works. And in the top left corner, we've got the X and Z coordinates of the camera. So if we're looking at this face straight on, then you can see Z is pretty low and X is pretty big. But if we look at one of these faces, then X is pretty small, but Z is pretty big. And if we look at the other side, then X is still pretty small and Z is still pretty big, but it's negative. And same thing for this plane. So over here, X is negative, and over here, X is positive. And that'll come in handy later. So that's the sample solution, but all we have right now is the coordinates label. And we've got a couple other functions that I left in because they're sort of beyond the scope of this video. So one is move camera. So it takes in the mouse X and the mouse Y. And basically what it does is it rotates the camera around the cube, or the rectangular prism, so that we know where the camera is and we can control where the camera is with user input. There's also this function which converts a 3D point to a 2D point using some linear algebra. And again, the algorithm is just from Wikipedia on 3D projection. So don't forget to cite your sources. But the main idea, again, 3D point comes in and 2D point comes out. And the last one is just a very small function to draw the coordinates label. So I'll actually do that right now. So in on mouse drag, we're going to draw the coordinates label. So let's run and see what happens. Okay, so I'm dragging the mouse, it's drawing a bunch of labels. Now we don't want that. So usually you would just change the value of the label, but what we're gonna do is every time we are drawing the object, we're gonna just erase the whole canvas and then draw a new object. So because of that, we're gonna do app.group.clear and draw a new label too, instead of changing the value. So if I run, well now it seems like it's clearing and drawing a new label, but the values aren't changing. So I think what I should do next is call move camera on mouse drag. So first we're going to clear all the objects from the canvas, anything from the canvas, then move the camera. It's X, mouse Y. So hopefully now the label should update with where the camera is. And it looks like it's doing that. But of course, it's hard to tell exactly what's happening with the camera because there's no object to look at. So we just have to go off of these coordinates. Let's see. So, okay. So I guess that's going well. That all looks good. What should we do next? Well, draw plane is going to be called in draw block. So let's do draw plane first. I guess you could do it either way. So draw plane. So draw plane is going to take corners. Now, corners is a list of 4 3D corners. So I'll do that in a comment right here. Corners. List of 4 3D points. So what we need to do is convert each point in corners to a 2D point. And then we're going to draw a polygon with the new 2D. Seems pretty simple. So let's make a list called new corners. It's hard because in Python you can't start variables with a 2, I think. Right? Because if you do 2D equals 5, it doesn't work. You can't do that. So we can call it 2D corners. So I'll just call it new corners. And I'll make an empty list. And then let's see, for corner, maybe for point in corners. And let's look at what the function was called again, convert to 2D. So I'll copy this, convert the point to 2D, and we'll make new X, new point. Because this returns a list with 2 numbers in it. So new point will be a list with 2 numbers, and then we'll just add that to new corners. So new corners equals plus equals, we'll add that on, new point. And then let's see, what do we have next on the list? So hopefully this will make, this will take all these 3D points and convert them into 2D points. And now we just need to draw a polygon with that. So it's pretty simple. Polygon, and then this is going to have 8 numbers in it. So new corners 0, and I'll just copy and paste for efficiency. So corners 1. So this is going to be like the x1, y1, and then we'll do 2 and 3. So this is the first 2 points. So x1, y1, x2, y2. And then so 0, 1, 2, 3, 4, 5, 6, 7. And I'll just move these down so they're easier to see. So these are going to be the 4 corners of the polygon. And then we'll make the fill equal to block color. And the border equal to, oops, this isn't block color. This is app.block color. App.block color, app.block border color. Okay. So now if we run, there are no errors. You might need to come back to it once we write draw block. But for now, we're good. All right, let's move on to draw block. Okay. So we're moving around. We need to draw a block now. And let's start with the top, because that'll be the simplest. Because unlike the other sides, which, you see this one sometimes, you see this one sometimes, you always see the top because we're not moving the view angle up and down. So to draw the top, we'll have to call draw plane, which we just did. So draw plane, and it'll take the top corners. But what are other top corners? Well, we have to figure that out. We do know that it's a list of 4 3D points, so let's make that top corners equals a list. So the first one, so let's say that we know the height is going to be the height that's given for the block. That's going to be the y. And by the way, these 3D coordinates are x, y, z, and y is the height. So it's the same way that is in Minecraft. So x and z are horizontal, and y is vertical. Okay, so let's see. One of these corners is at 0, 0. So let's say 0, 0, and we know that y is going to be the height. So we have that one done. Let's just say that this one is 0, 0. Well, the next one is going to be, let's see, it's going to be, instead of 0, it'll be length far away. So length, height, and still 0 because the z-axis hasn't changed, but the length has changed. And now if we go to this corner, now it's length away from 0 and width away from 0. So we'll do length, height, width. And then we'll come back to this corner. And now this one is 0 away in the x, and still at height. But it's width away from 0 in the z direction. So these should be the right coordinates based on the height and length and width that's given in the draw block function. And again, I don't know if this is really 0, 0 in terms of x and z in 3D space, but I'm just going to assume that it is when I'm thinking about what these corners should be. So let's run, and looks like the top is the same for the starter code and sample solution. So that's good. And if we rotate, nothing, it disappears. That's because, oh, I see, we're not calling draw block and on mouse drag. So we called it once here at the beginning, but we also need to call it an on mouse drag. And so this is why we have app.group.clear. So we're just clearing everything from the canvas and starting fresh. Because if we didn't do that, it would be a whole mess. Although it's kind of interesting to see the path that this at the top goes on. It's like an oval. But to have the sort of animation effect, we're just going to clear the frame every time and start fresh. All right, well, the top is done. That wasn't so bad. Let's move on to maybe one of the sides. So I guess we'll do this side. And this side is, we're closer to the positive z, and x is 0.25, and so that's in the middle of this block. Because the width is 0.5, or the length is 0.5. Sorry, so the length is 0.5, and so we're looking at the middle, and so that's 0.25 for the x. All right, so let's get going with the next one, and I'll call this long side as opposed to the wide side, because this is the length with 0.5, so long side corners equals something that we'll figure out, and we'll have to draw a plane alongside corners. All right. Now let's think about where these corners should be. So one is going to be at 0, 0. And I think, again, it doesn't matter. So we'll just call this one 0, 0. So one of them is going to be at 0, 0. And 0 height as well, because it's on the bottom. Another one is going to be still at a height of 0. So I'll put the 0 in the middle there. But it's going to be length away, because if this is the x-axis, so it should be length. And width is still 0, so we're not going along it. And now we're here, we're going up, so we're still at length along the x-axis if this is 0, 0. But now we're at height. And then finally, we're over here. So x is 0 if this is 0. So 0, 0. But the height is still at the height of the block. And z hasn't changed at all. So this is still 0. And let's see what happens. All right, so it turns out 0, 0 is on this side. On the far side from us, it looks like. So if we turn around to here, then we can see what we did. So it turns out 0, 0 is down here. This is the side we drew. So you can see two problems here. Number one is that they're being drawn in the wrong order sometimes. So if you look at it like this, then it looks fine. But if you look at it like this, then it's kind of weird, and it looks like a different shape almost. And it's because we're drawing this vertical plane in front of the top. And really the top, if you look at the sample solution, should be on in front of everything else. So we can change that really easily. We will just take the code we had to draw the top, and we'll move it after we draw the long side. And make sure that the alignment's good for the code, all the indents and stuff. And so now it looks a little better. So the top is always in front of this side, so there are no problems there. But the other problem is that if we're over here, we want to see the side that's closer to us instead of the side that's farther from us. And okay, how can we fix that? Well, to draw a side that's closer to us, we're going to have to add, what are we going to add? We're going to have to add, I think, length to this. So, or not length, we have to add width to this. So the width of the block is this part from here to here. And so we're going to move this plane, which is right here, we'll move it by the width of the block, so that if we're looking at this side, it'll be closer to us. So let's just try that. So instead of 0 for the z, we'll do width. Oh, now it's closer to us. Just like the sample. But if we move over here, now it's farther from us. And so we want to change based on whether we're close to it. So what do we have it for? If closer to this side, we'll draw it with the width. Otherwise, we'll draw it like we had before without the width. And what does closer to this side mean? It's a good question. Well, let's take a look. So right now, x is 0.25 and z is 3. But now for on this side, z is -2 and x is again 0.25. So z is large here and it's negative here, positive, negative. So maybe if z is greater than 0, and by z, of course, I mean f.z, then we'll draw this side. Okay, let's see how this works. And if it's not, we'll draw the other side. Oh, and it's switching. So, right, so if this side is closer, we draw this side. And if this side is closer, we draw that side. Seems like it works pretty well. There are these edge cases where you're looking at almost both of them at the same time, but not quite. But this seems pretty good for now. Let's add the wide side and then see what happens. Okay, so if we'll do the same thing as we did with the long side. So if app.x is times greater than 0, then wide side corners equals, let's see, take another look at this. So the wide side is this one. So let's just say that this corner is 0, 0. And if it's not, we can edit it. So 0, 0 here, 0, 0, 0, 0 height, 0 width, 0 length. And we'll go this way. So over here, now this is the width. So the length hasn't changed, the height hasn't changed. The width is now width. This is width away from here. If we go up, now the length still hasn't changed, but the height is height. And width is still width. And if we go over here, still no length, but we have height and we have no width. So let's see on our model. Seems like we don't have either, but that's because we should call draw plane with the wide side corners. Wide side corners. All right. So looks like we picked the wrong side because it's drawing the one that's farther away from us. So we can just change this to if x is less than 0. And now if we're closer to this wide side rather than the wide side that would be here, it draws it. So we'll just do something similar to up here. And we'll add an else. And now in this scenario, we're closer to the other side of the block, and these will all be shifted over by length. All right. Well, this looks pretty good for the most part. So it's drawing the sides that are closer to us. It's only drawing 3 sides, like I said. So only calling draw plane twice. But you can see there's a small problem that we don't have in the sample solution, which is that sometimes the wide side, which is being drawn after the long side, should actually be behind the long side. So maybe if we change the order, maybe that would help. Maybe if we draw a wide side first. It seems to fix it there. But now we have the same problem here. So this is another thing about drawing 3D objects, is that you have to figure out the order in which they should be drawn. Now, we already figured out that the top is always going to be drawn last. But depending on where we are, we either have to draw the wide side first or the long side first. So I'll move these down here so that they're next to each other. And let's see if we can figure out something with the camera coordinates. So right now, x is small, z is positive and large. And if we're right here, now x is negative and large and z is small. And this is where we want to draw the, I believe this is the wide side first. Or second rather. Because right now we're drawing the wide side first and the long side second. So the long side is on top of the wide side. So this side is on top of this side always, which it shouldn't be. So right now, z is small, and we want to draw the long side first. So maybe if the absolute value of app dot x, because it doesn't matter if it's, I don't think it matters. Hold on a second. It shouldn't matter if x is positive or negative. It's just as long as x is larger than z, we're going to draw the wide side second. So if absolute value of x, magnitude of x is greater than the absolute value of f dot z, then we want to draw the wide side second, so it's on top. Otherwise, we will do the opposite. So wide side first, then long side. And everything looks good. So there's no problem with overlap. And all of the correct faces are being drawn in the correct order. And the ones that are closer to you are being drawn instead of the ones that are further from you. Well, looks good. This has been a very simple introduction to 3D graphics. As you can see, even this is pretty complicated, but not too complicated. So I'd encourage you, if you're interested in this, to play around with it more and maybe try to add some of your own features. Thanks for watching and enjoy CS Ed Week.